joining us today. And we are really fortunate to have today Mr. George Salazar with us. So, to tell you about him, I studied a lot about him for the last 1 week, and I got to know that uh, he has been giving contribution to almost every major American manned space mission, including Space Shuttle and ISS. And now he's currently a human computing interface technician, a discipline head at NASA, and he has also been known to establish the education outreach programs and partnerships with and collaborations with the numerous of universities, and apart from this also a lifetime achievement award winner. So welcome, Mr. George Salazar. It's good to have you here.
Thank you. Pleasure to be here.
All right. So before we get to all the questions and the live questions that we'll be receiving here, I would like to know about your work. Like, what exactly do you do, being a head of the human computing technical interface?
Okay, so the primary responsibility for that group, the group that I'm in, is that we basically manage or are responsible for all the human interfaces that astronauts use. And it's not just space shuttle and space station. Obviously, space shuttle has been retired, but now space station, but also the commercial crew program. I'm personally involved with the SpaceX human radiant systems, the Dragon 2, and also the Starliner, which is the Boeing CST 100. And so the commercial aspect of human interfaces I'm involved with and have the responsibility on the NASA side. In addition to that, we're also doing a lot of what we're calling futuristic type research associated with what kind of human interfaces are going to be needed for future space flights, like, for example, going to Mars. And even obviously the moon and going to Mars. There's so many challenges that are posed there for human interfaces because as we get further and further away from Earth, there's going to be more dependency on the onboard spacecraft systems rather than mission control. And the reason for that is because of the time delays of communicating between mission control and the spacecrafts. So there's going to be a lot more sophistication on those spacecrafts. And as a result, we have to look at better ways of managing and controlling those interfaces. And more importantly, to minimize human error, because these are they're going to be complicated systems. And we want to make sure that they're also very somewhat easy to use. And it doesn't pose any issues with controlling the spacecraft. So that's basically the area that that's my responsibility. Things like wearable technology, imaging, lighting, audio systems, speech recognition systems, haptic interface systems, where you touch and vibrating, things of that sort, are some of the areas of our responsibility. And we got universities doing some work for me in that area too as well. One of the big ones is what we call graphics processing unit technology. So if you look at Star Trek, you look at the holograph, you look at all this imaging and images of a spacecraft rotating, all that. That's all graphics processing unit. Well, that's television. That's the movies. In reality, that kind of processing power that we're probably accustomed to, for those out there that are used to gaming, that kind of technology does not work in deep space because of the radiation effects on electronics. The radiation can really play havoc on electronics. And so one of the things that we're looking at is how can we build and design systems that use graphics processing for some of these deep space missions. We've taken some graphics processing units to radiation testing at Indiana University and some other radiation test facilities, and they just didn't fare well. So that's another area that we're looking at too as well.
So that's really, I guess, a lot of work that you've been doing and your team as well. So, like, I really wish you best of luck for the future human interface tech, missions, the things that you'll be building up for the future human spaceflight missions. So, Mr. George, actually, I have been fascinated by the space and whole rocket stuff since my childhood, right? So, I just want to know about your journey, like how and when did you realize that you are getting fascinated by space?
Okay, how did I get fascinated by space? So I have to say that early on, I was very much into some of the comic book heroes, some of the superheroes, the spaceships that I would read in comic books and things like that. And that was my fascination. I love reading comic books. Batman, Superman. I even read some of Buck Rogers, and so that fascination started very early on. There was a series that was called Rocket Man, and so he had rockets on his back, and he had a control, and so what he could fly, and he fought criminals and all that. So I used to find Coke bottles, and my older brother would put them on my back, and I would put a paper bag with holes in it and a helmet, and I pretend I'd be flying around. But the whole thing about space started to become more interesting when the Apollo program came on, and I used to watch that on TV. That was just amazing. When I still remember when they landed on the moon, a lot of people in my family did not believe that happened. They said, "No, no, that can't be. That can't be." But it's true. And then, of course, all these sci-fi shows I love. It was just fascinating. I always had a fascination for science and technology. So it was it was part of the influence of me. I guess where I am now.
Okay, that's really like starting from all the childhood and the inspiration that you got and finally landed up here in NASA. That's really inspiring to know. So, how did you actually get connected with NASA? Please, I would like you to share some of your experience with the viewers.
So, I mean, my connection to NASA obviously is I work for NASA. I came to work for NASA after graduating from the university in electrical engineering. But getting to that point was a rather lengthy road because I wasn't a very good high school student. I graduated 475 out of 605 students, and so the road going to NASA was a rather long road. There was a lot of paths that I took along the way, but to make a long story short, I, um, I have to say that one of the things that helped me was that you it's called perseverance, which means don't stop, and it's helped me along the way. Even after joining NASA, there was a lot of challenges, just learning the technology, learning. All the things I had to learn new. I thought when I got out of the university, it was going to be easy to understand things at NASA, but there was so much new stuff to learn. I was learning every day. So it's and of course I started with the shuttle program and then went on to the space station program, and then I started doing experimental flights and experimental spacecraft design and development too as well. I have to say that it's been a pleasurable journey so far.
A pleasurable journey for you. I'm sure that this journey is going to be an inspiration to a lot of viewers who are joining us, still joining us. So, sir, actually, Indian Space Research Organization is also now looking forward to the manned space missions, right? And we have also sent three of our test pilots from Indian Air Force for training at Roscosmos. So, what like I want to know how is a space agency going to prepare itself for the manned mission to Earth orbits?
Okay, so agency like NASA, we pick. obviously people from universities and they have I guess a lot of creativity. Obviously, engineering is huge at NASA. I would have to say that at the Johnson Space Center where I work, one of the 10 centers, has over something like 65 to 70% of the people there are engineers and scientists. So, but to prepare ourselves, um, every time we've taken a mission on, let's start back from Mercury. Okay, the Mercury program was to understand and learn how if humans could even live in space and work in space. And then the Gemini program, the next program after Mercury, was how can two spacecrafts dock together and rendezvous together, because that was going to be very critical for the Apollo space program. And then, of course, the Apollo space program was to land a human on the moon and return him safely to Earth. So each one became more and more complicated, but we learned more and more about what it takes to fly humans in space. What are all the necessary systems to keep astronauts alive? What kind of communications do we need? Life support systems, extra vehicle activity spacesuits. All these things are important. So, in order for us to continue preparing ourselves for future, human spaceflight missions, we have to keep learning, and that's why going back to the moon is going to be critical, because we have to live and learn how to basically live on another planet and live off the planet. We cannot take all the food and water that we need for, let's say, for example, Mars is a 3-year mission. We cannot take that amount of food with us. So we're going to have to learn how to use the resources that other planet has, to keep humans alive. But it's everything that we've done in the past up until this point is preparing us for the future of lunar operations and living on the moon, taking all that knowledge and then carrying it on to Mars.
All right. So, talking about the Von Allen belts, right? These charged particles are actually a big problem for the spacecraft and the humans as well that are going in the spacecraft, right? So, I just wanted to know, like, what all effects are experienced by the spacecraft and the crew due to the Von Allen belts.
Okay, yeah, that's a very good question. So the Van Allen belt, and obviously there's two Van Allen belts, kind of like an inner and outer Van Allen belt. And the inner Van Allen belt basically traps, because of the Earth's magnetic field, a lot of the protons and high energy particles. And then the outer belt equally traps a lot of electrons and other high energy particles. So even back in the 1950s and even 60s, they understood that the radiation, that kind of radiation on the human could pose a lot of medical problems. And as a result, there was a lot of thought process in how can we go to the moon, because it's all the Van Allen belt, both the lower and the outer are on the way to the moon. And so they figured that they had made some calculations of how much radiation the astronauts could experience going to the moon. And so they found that if they went a certain speed, I think it's 25 kilometers per hour, that they would basically last, depending on the trajectory of going to the most minimal part of the Van Allen belt, they would be exposed to about 52.8, roughly about 53 minutes of radiation exposure. And so it turns out, because of those calculations and trajectories, that the amount of radiation that they got was equivalent for something like 2 CAT scans or something, here on Earth, getting a CAT scan. So it was very minimal. And so the important thing was go as fast as you can through the most minimal part of the Van Allen belt, and you'll be okay. The Van Allen belt issues. Well, I mean, once you get out of Van Allen belt, I think we got that pretty well covered, so to speak. The more challenging part is the deep space radiation. As we go further into space, going to Mars is going to, there's a lot of radiation exposure. And so how can we protect for that? We're looking at different ways of how we're protecting that. Certainly it would be great if the spacecraft could create a magnetic field like what the magnetic field does to protect the Earth from high energy particles. If it wasn't for that magnetic field, I don't think there'd be life on Earth as we know it. And so the challenge now is how can we develop very effective radiation protection for astronauts going to deep space for a long period of time. And so they're looking at things like water and other elements and stuff. And there's pros and cons for each one. But in the end, the thing is about weight for a spacecraft, because the more weight that you have, the bigger the rockets have to be, the more fuel, the more expense, the more complexity, the more cost. So there's always trades involved with all that. And that's something of the things that we're studying. Oh boy, there's a whole bunch of things that affect the human body. Our bodies were meant for the one gravity environment that we're currently in right now, and so when it goes to a microgravity environment, it tends to change the physiological operation of the body, if you will. Like for example, one of the interesting things about going into microgravity, which I could appreciate, is that astronauts grow a little bit because there's no longer the force of gravity on the human body, and so your body tends to expand a little bit. So you can grow somewhere around 2 inches. The other, of course, there's also some negative effects. Like for example, because of the microgravity, there's no sinus drain. If you've ever seen some of the pictures of astronauts, their face look kind of bloated, and that's because there's no. If you have sinus problems, you cannot drain in space. The fluids stay around your face, and so you become a little bit bloated. Some of the other things that they found is the eye starts to kind of become elongated, so to speak, and so you become myopic. And so that changes your vision to some extent. Your blood flow is altered. Your heart is altered too as well. And so these are some of the things that 1 year study that Scott Kelly did, where he stayed 1 year on the space station. They found all these kind of effects that were happening on the human body because of the microgravity environment. But keep in mind that Scott Kelly just did 1 year. Going to Mars is 3 years. So in the microgravity environment, we're talking about 18 months. Or maybe even more of the body experiencing that. And you're also adding radiation effects. So the blood tends to behave a little differently in the microgravity environment. And how is that going to affect the human body? So those are some of the big challenges that our Human Health and Performance Directorate, which is involved with the human health of the astronaut, are studying.
Okay, so sir, in continuation to the same question, there's this question put forward by Swapnil Parekh. He asks, what type of challenges are faced by astronauts who will be traveling to Mars for like 8 to 9 months?
There's the challenges of boredom. Okay, so as I mentioned previously, some of the sophistication of some of these systems they're going to need it for Mars is a lot of autonomy and automation. Well, if the spacecraft is handling a lot of that, that doesn't give much for the astronauts to do things. So there's pros and cons with that. It probably gives them more opportunity to do other things, they like entertainment or whatever. However, the problem is that if that autonomy goes bad, how can the astronauts regain control of the spacecraft if something goes bad? So and if they haven't operated that system in a long period of time, let's say 4 to 5 months, they have to remember, how do we do the system? So that's some of the challenges of human computer interfacing. We call that human systems integration, where you have all the elements associated with the human, and making sure that we've optimized this system for the astronaut, in both the case where everything's going perfect, and then the case where things aren't so perfect. The other challenge, obviously, because of traveling that far, is the one that's of concern, is the psychological effects. Depression. I miss my family. It's not the same as being close to Earth and doing isolation. I remember talking to a Russian scientist many, many years ago, and he said, they did all these studies of isolation in Siberia for a year or even more than a year, with some of the test subjects. And interesting enough, he said one test subject told him something that he had never heard before. It was never recorded, but he shared that with him, and he said, the only reason that I was able to stay here in isolation for over a year was because I knew I was on Earth, and then I knew one day that door is going to open and I'm going to get out. So it's different if you're going to Mars, because now Earth is starting to become smaller and smaller, and then you start to realize, hey, I am moving further away. So we're still not sure how the behavior of the astronaut is going to be going into deeper space, and that's why the other thing about human computer interfaces is understanding the physical and psychological health of the astronaut, and whether a autonomous system needs to take over in case of an emergency.
All right. So, like talking about the psychological problems that the astronauts will be facing during the space flight, this is something that they are going to deal with it by themselves, right? But about the biological challenges, what precautions are taken in order to reduce the effect of these things, like specifically gravity? Like, for example, you told about the strain and the uh, face getting swelled up, right? So, what all precautions are being taken to in order to minimize the effect?
So, I mean, one of the things that this has been going on for many years is the talk of a rotation to create a artificial gravity environment. And so there's obviously, here again, pros and cons, and that's something that as part of the engineering design process is to figure out, what's the optimal way of doing that. Creating an artificial gravity environment is nothing new. The gentleman of von Braun, that basically was the inventor, the author of the Saturn V. He thought of a rotating space station and creating artificial gravity. But keep in mind that, and this has to do with reliability of systems, which is very important to NASA, is mechanical systems tend to break, and so you have to be cautious about what you're trying to achieve, but also make it reliable. And so when you have a huge rotating craft, very large mass, is you have to be cautious about how reliable that's going to be. Certainly that's going to help the astronauts, but if it's not reliable, it's of no use to them if it breaks down, 3 months into their flight. So, and then the challenge obviously is, how do you test something that huge? Well, maybe that's going to be part of our strategy, is to develop some kind of artificial gravity test article, if you will, and we orbit around the Earth and then test it here near Earth, and that way, if something goes wrong, there's a way of getting out and coming back to Earth very quickly, rather than trying it for the first time, going out 45 million miles and this thing breaks down. And unfortunately, there's no repair stations along the way to Mars, so it'd be very challenging.
Okay, so actually, honestly, like from this answer, till date I thought that building up some space station which revolves like this, having some sort of circular motion, is going to be the next like I always had this in mind of designing some sort of thing, but now that you told me that things tend to break when they are rotated like this, I've got to keep this in my mind while designing it, right? So I'll take care of that in the future. Right. So about talking about the space flights, do you think in the near future, or by probably by next century, the human space flight is going to scale up to intergalactic levels?
Oh, I would love to, in my lifetime, see kind of like the Star Trek situation where they go anywhere from 1 time to 10 times the speed of light. Of course, there's some challenges going to the speed of light, but I mean, I would say that perhaps in the next century, I would love to. I would love to, if I was around, that we develop intergalactic travel. I have to say that obviously there's many challenges as if I discuss about the physiological and psychological effects of traveling long distances, and of course the complexity of the systems. But I think we're going to have to get into some kind of accelerated technology development program, very comparable to, I would say, something like the intelligent microprocessors. Moore's law said that every 18 months the technology doubles in capability and complexity. And we need to do something like that. I think at this point in time, to let's say 100 years from now, that we'll be able to travel, beyond our solar system with humans on board. I wish it was easier. 100 years is just amazing. I was at a conference where there was a Boeing employee. He gave a presentation of the early airplanes 100 years ago at that time, and where and the airplane used to break down just about every 100 miles. And so when they did their first cross country across the United States, they had to land something like 15 times to fix the plane and then keep going. Well, and then of course now we're flying. It's not a big deal now. Flying from now they're talking about flying nonstop from New York City all the way to Australia, nonstop. But we're very fortunate that we're here on Earth. We've got a lot of air. We've got food. We have all these things. Intergalactically, it's going to be a little more challenging. And even if we conquer the technology challenges, I'm still not sure about the human challenges of being away from family. The psychological effects of doing intergalactic travel. There's some of the things that we've been discussing as things like telepresence. How you have family members appear to be close to you, and you're talking to them. But again, as you get further away, the communication signal takes longer and longer to get to the astronauts and then back to Earth. So maybe one day we'll be doing that, but I think we need to accelerate that technology, and of course that's where the commercial sector comes into play, and that's why the commercialization of space I think is one of the key factors. Is because I think commercial has a lot of ingenuity. They have a lot of innovation. And so combining them with NASA in some fashion, that we can collectively come up with some solutions that maybe would have taken a little bit longer without factoring in the commercialization of our commercial companies coming into play and helping NASA accomplish our missions.
So, sir, talking about the private space agencies, like apart from these private space agencies like SpaceX, then Boeing, and even we've got Blue Origins, right? What apart from these companies, what do you think about the startups? Like, how do you think startups are going to be a help to the human space missions?
Oh, okay. For the startup companies and space missions. Okay, so like right now, there's a lot of opportunities for returning to the moon. Already, we're getting competition with commercial companies bidding for human landers and all different kinds of. I mean, it's just incredible all the opportunities to get involved with human exploration right now. One of the big challenges is going to be, as I mentioned previously, is living off the land. So who is going to come up with a very reliable way of taking soil from, let's say, the moon or Mars, and converting that into water for the astronauts and for growing for growing plants, for creating fuel for rockets. And of course, here's the challenge: is that these machines are going to be huge, and so how do we land something that big on a planet? And of course, as I mentioned, more weight means bigger spaceships, means more complexity, more cost. And so those are the challenges. But hopefully, the commercial sector will help us try to solve some of those problems. But there are just so many things that we need, in order to understand and live and learn and work on another planet.
All right, sir. So we'll be now after this question, we'll be taking up the live questions. I guess they're pretty interesting audience. They've put really amazing questions here. Right. So just this one question. Actually, this question is my favorite one. So what do you prefer, a safe up-down trip to ISS or a one-way trip to Mars?
Okay, so I guess which one would I choose if I had a one way trip to Mars, or or go to a station and then come home? So it's interesting because everybody has their own level of risk, right? And so for me, I guess I'm no longer the risky type person that I used to be when I was younger. And I would personally just go to a station, and I would just love to view the Earth from station, and just spend hours just looking at Earth, and then coming home, coming home to family. But there's folks out there that they'll say, you know what, I want to go to Mars one way, and if I don't come back, that's the way that goes. So it's just a level of risk. But for myself, I'll stay with the visit station and then come home.
How will artificial intelligence and machine learning be useful for Mars colonization to sustain life?
Okay, so machine learning is going to be a huge one for future spacecraft missions. As I mentioned previously, because of the time delays associated with communicating between Earth and the spacecraft, we're going to have what I guess we're calling onboard mission control. And so mission control is going to be machine learning that's as the spacecraft is evolving, it's changing, or things are changing. The machine learning is going to be a vital part of updating and improving let's call it the vehicle doctor, if you will, to analyze the spacecraft, to analyze the people, or the astronauts and crew on board the vehicle. So machine learning, artificial intelligence is going to be a biggie.
Okay, so sir, actually, I want you to tell all of our viewers about all the different space missions that you have worked on till date, and share some experience of that.
Uh, what missions? I'm sorry, the missions that I've been on, or
Yes, exactly, the missions that you have worked upon.
okay, well, boy, I mean, for space shuttle, I was involved with quite a bit of missions early on from STS-7. STS-7 was the first female astronaut by the name of Dr. Sally Ride, and that was on Challenger. Many of the missions early on, I was involved with. We had the first Afro-American to fly on the space shuttle. I was responsible for the modular auxiliary data system on the space station, or rather space shuttle. And so I had the responsibility of um, different missions and capturing data from the shuttle instrumentation system. Um, I've also done the X-38, which was a very interesting spacecraft, experimental spacecraft, and also I was involved, with upgrading the space shuttle, and it uh, mission, and then of course now I'm doing these commercial spacecraft missions too as well. But I have to say that a lot of my work was, doing space shuttle. Okay, so do I believe space is for everyone? What's my take on that? So I agree that space is for everyone. Nobody owns space, but we have to be respective of space. We have to respect, how do we live and learn and operate in space? We just can't be launching spaceships into space and not cleaning up after ourselves. Right now, we have so much space debris out there. It's getting a little bit more challenging for orbiting satellites. And even though space is large, I mean, we continue at this rate. We may have so much junk in space that we may not be able to launch at all. So we have to understand that, space is for everyone. I 100% agree, but we have to do it in a systematic and respectful way.
All right, sir. So since like you told us about your journey from your starting from your school, then high school, then the university and all these. So as you told us that your journey has been a lot of zigzag, right? Right. So I guess like your message to all the aspiring space enthusiasts would be really helpful.
Okay, so I have to say that, I mean, for myself, coming from the uh, ghettos of Corpus Christi, Texas, to where I am now. It was, like you said, it wasn't a straight line, zigzag all over the place. So for those that out there that are aspiring to to work in the space program, to maybe do a startup of commercials companies, I have to say that the key ingredient is perseverance. Okay. One of the things that I have found over the years is that universities sometimes make an assessment of how good you are based on your grades. And I'm an example of that's not the case. I wasn't very good at taking tests. I wasn't very good at some of that stuff, but I learned how to use what I learned and do it effectively. And as a result, I got some patents along the way. Done a lot of contributions to the space program. But I have to say that for you out there that are wanting to aspire to work at NASA, to keep that dream alive, write it on a piece of paper and just keep it in your wallet or keep it in your purse, and just keep going back and looking at that. There's going to be a lot of challenges, but perseverance, determination will help you get there. There's one lady I know from India that she was a high school student, and she reached out to me. This was almost 6 years ago. She wanted to come work for NASA, and I gave her a recommended path. I said it's going to be a long one, but you'll get there. Well, almost 6 years later, she's working. She's going to be working for a professor at Berkeley, no, Caltech in California, and that professor also works at Jet Propulsion Laboratory, which is one of our NASA centers. So long journey, but she stuck with it. So stick with it, perseverance and dedication. Don't let anything stop you.
That was quite inspiring words from Mr. George Salazar. So it was really nice to have you here on the webinar. I guess I'm pretty sure that you have also I've already inspired a lot of people, and you inspired a lot of people here through this webinar as well. And at the same time, I'd like to also thank all the viewers who joined us today for this amazing webinar with Mr. George Salazar. And Yes, about the next webinar, guys, we'll be having the next webinar tomorrow at 7:30 p.m. Indian Standard Times. That will be with Ron Sparkman, and tomorrow the host will be none other than Mr. Sunny Kabrawala, right? So we'll see you there. And sir, thank you for sparing your precious time with us. It was really nice to have you on board.
Likewise, thank you.